The reason why we started using modems and when you need them.
Wireless access points,
Bridges,
bridges,
backhauls, hotspots. We're going to talk about that. So we'll start with these old modems. That's how we started back in 2002. You can see these modems. If you look at it, it looks like a circuit board. Randy found them, and we decided how we're going to hold it because we had to custom make this metal bracket. That's why you'll see these metal plates on this, so we could click them on and put them in. If you look at those modems, it'll say transmit, receive, and power. Well, you'll understand that this has no I/O. And in order to make a basic input and output on both ends, you have to have pairs. And you also have to have a PLC. And the PLC had to communicate with the radio. So you had to have two devices. You want to close an input on the host side and close an output on the other side. You had to have a PLC, a radio on both ends in pairs. The reason why we used the modems back then is back in '95 we would run wire all over the feedlot, starting pumps in different areas, and it kept breaking. We would go out there once or twice a year, finding the break and splicing it, and have all these problems. It was very frustrating, and we needed to come up with a better solution that was not so expensive from all the trenching and digging and wire. And that's how we found those modems. And we started using those. Got some samples that we did.
So those are serial modems.
They're serial modems, by the way.
RS-485 serial. They're very slow. You can't pass much information. And if the information drops a packet or two, then whatever was in that packet, the on, the off, the whatever, it just went away. So the systems would be like doing weird stuff occasionally because we did it with Rainbird systems, we did it with lots of different things. Well, that information just got lost. There's no error checking.
There's that modem you're looking at back in 2004 for a feedlot with 3 remote wheels panels. Those modems use a communication protocol called Modbus. Modbus is a protocol that's been used around for years and is industry standard for communications. Modbus RS-485 is a 2-wire, which is half duplex. When you transmit something, you have to wait for it to receive. There's also Modbus what is this? 422. That's full duplex. It's 4 wires. It's full transmit, full receive. We don't use that because ABB only supports half duplex or S485. So we stuck with that, and we still do. And that's still the same thing we're doing.
That panel that you looked at was communicating with those drives, RS-485 Modbus. We do it all the time. It's really robust. Even though you can do it Ethernet, and we do that occasionally, or we'll do both, the Modbus is still more robust than Ethernet.
The PLC was communicating with the drive via Modbus?
Yeah.
Okay.
Well, you still have an Ethernet hub in almost all your boxes now, right? And you take in information from all the remotes to, okay.
But when we're sending start-stop bits and those kind of things, we typically do it over Modbus and not over Ethernet.
Okay.
We don't use, in the new configurations, we don't usually run wire for start and a wire for stop and a wire for this and a wire for that to the drive. Most of the time we just send the set point, the start bit, the stop bit,
I mean, from a PLC to the drive. On the newer PLCs, they can support up to 7 communication protocols. On these IDEC PLCs that you saw, they can have up to 7. There's 1, 2, 3, 4, 5, 6, 7. So rather than putting everything on one communication, if you lose a well site like this one out of 5, there's a lot of latency. That's one of the disadvantages with Modbus. When you have too many nodes in the field, you drop one, then there's some latency. It starts slowing down and you start having problems. This is one of the reasons on these older systems, we had quite a few of these. We started realizing every time they shut a well off, the whole network would just bog down really bad. So here's a typical setup on site. Remote well panel on a pole with the Yagi antenna pointing back to the host site.
A lot of cities, this is still the same, they still use this.
Yeah.
All, this is still very common in municipal water.
CUNA does.
Blows my mind, huh?
CUNA does.
Yeah, yeah.
They use it on their irrigation.
Motorola.
They've got one guy.
This is what Motorola does, even today. You buy a new system, a lot of the Motorola systems are still like this. It's like, oh my gosh, really? Of course, they're in the radio business.
Yeah.
Okay, on the newer ones, we started using these Max Streams, Dixie Max Streams, instead of those old ones, because it's much nicer than a case. We still use them. So, and everything's on a 9-pin port. This is great for point-to-point applications. So,
Like 9 pins.
Like Steel 9?
they call them Extend now.
Extend.
It's made by Dixie.
Yeah.
Yeah, Digi bought that company, Maxstream. Digi bought them. Those are very common. Tons of people use those for.
900 megahertz.
Yeah, we've got them all over the place.
Yeah, cheap.
Mm-hmm.
And they work well.
Yeah.
Mm-hmm.
Yeah, they work real good. Sometimes we'll have to run an antenna up to get over some houses or whatever. They work good.
We have real lightning prone places and they just want a point-to-point communication. How often are you seeing any fiber optic now?
Quite a bit. We're doing everything we do for the LDS church is fiber. We do that municipal water system we did last year at Sandy, Oregon is fiber. Those switches that's switch we put in our box has got a fiber port on it.
Yeah, yeah, I used it there at Cold Spring. I was just wondering how common it is because
It's getting
seems
more and more
pretty
Yeah.
dependable.
You know, the thing that they need to do is they need to get out and teach people how to use fiber so that you can go buy the fiber and, you know, so you're not doing some contractor that does municipal fiber. I mean, fiber is really simple to do, but they've spent zero time marketing it and training people how to use fiber. And the first time you do it, you know, you're all nervous about it, and then you realize it's like, wow, this is so much easier and faster than
Big
wire.
optical isolator.
Oh gosh, it's just,
Yeah.
you can still do wire installations like we did for Joe. Here's an example.
That is Marshville.
Yeah.
That's a perfect drawing. You got
See that? Goes underground.
That's a
Customer Okopum.
Okopum.
That's the code. That's the customer code.
Alex, will you go ask Jennifer where she put my scan document?
His name isn't Joe anymore to me.
Yeah.
You're now Okopum.
Yeah.
Oh yeah, this is Tom's.
That's Tom's
He's got
sketch, is
a
it?
lot of systems out like that.
That's a view.
he still does that.
He still does.
It's
Yeah.
hilarious.
What, the sketch? You do not have to be a genius or hire an engineer. You can actually do this yourself.
You gotta sign the bottom of it though.
Well,
Or
Tom's not
something.
here, so we can rib them
Okay.
all we want.
Yeah,
Funny thing is, he
waiting.
doesn't even care.
He doesn't
care
That's
about
Tom.
it.
Yeah. Oh yeah, Tom's our weapons guy. If you haven't met Tom, he's our weapons specialist here at Precision Pump.
Okay, hold on a sec. I've got some more sketches on how to scan.
Tom's a competition shooter.
Yeah.
Isn't Martin as well?
Yeah. Oh yeah.
Those guys are like serious. Have you talked to Martin about that?
Mhm.
Holy cow. Check out my new piece, Dave. I'm like, whoa, awesome. Is Rob in here? So, Martin was here. He said, check out my new piece. And I'm like, did I show you mine? And he's like, oh yeah, you showed me that. And Rob's like, well, aren't you going to whip it out? And I'm like, I don't carry it on me. I'm not like Martin. Randy told me I couldn't.
Yeah.
Okay,
Concealed carry poster boy for Idaho.
all you guys need to do is just be a child again, get a notepad and a pen and go out on the field and sketch it up like that.
Or a crayon.
Here's an example of a tank we just did. Really simple. I will always ask you about any obstruction or any hills that may go in front of it. Because that I need to know. Because it helps me determine if you're going to have obstruction. 900 megahertz will not go through dirt very well.
Ag Industries, Sydney, Montana.
Yep.
I know this.
More
Yeah.
town drowning.
There's an American pump, a level sensor going into the ground to the pump house, wireless over to where the well is. Something like this, really simple. That's when you would use these. These PB2s made by Banner, DX80 PB2s, really small, 2 input on one end and 2 output on the other end, 1 analog in, 1 analog out, vice versa. Low cost solution, 2 of those, and you're on the right track. Yeah, there you go. So,
Well, that's the communication portion, but what do they have for, you got an existing PLC, or do you supply a PLC in with the well controls?
if there's an existing PLC,
We supplied everything.
You supply everything? Okay. But the comm link for this one was minimal, a couple $100. Geez, that's really good.
I mean, you can, if you only gotta go a few hundred feet, those are $80 a piece or something.
so all these drawings make it very helpful if you can get the overall scope of what you're trying to do. Then I would call and get questions from you. There's a remote pressure transmitter. The only place to get a transmitter, and the well pump is far away, for 200 feet. Is this expensive? Yeah, because 200 feet is very close. The difference between 100 or 200 feet and 1,000 feet of all that wire and labor and trenching, it pays for it. Does that make sense? So if you decide, do I want to get the trencher out, or just go wireless and be done with it? Remote pressure transmitter goes over wireless and goes back in the drive. Start the drive and release pressure over here. Okay. And this is the end of pivot. That's not a very good description for a pivot, Tommy, but close enough. It's an end of pivot because when it goes up on a hill, the pressure changes and it's not enough. You can do it that way too. You put pressure at the end of a pivot, and the drive will speed up every time it climbs a hill. Alright, there's a PLC box, 2 tanks. That's the IDEC color touch screen with the modem. Oh, that's a school building. And 2 wells. They're all connecting. Something like this would probably be Ethernet because it can all connect to one point.
So when you say Ethernet, that's these Ethernet radios, Ethernet wireless access points. Depending on how these are configured, you end up with a wireless LAN or a wireless mesh when you get done if you use 2.4s. So you put a couple of these up, and now you've got that whole canopy. Now you've got internet service, high-speed wireless.
North Dakota,
Yep.
2 remote wells, quarter mile apart, to 4 miles to the booster, and 6 miles to a tank. When you sketch this all up, I put all the notes in and everything I could think of what you plan on doing with this whole scope of operation. You have to think thoroughly through everything in order for it to work right. Agriculture, farmer has a deep well locally right here with a lag pump on the side, and down about several miles you'll have more deep well pumps, all interconnected the same main line. This main pump will start the first lag and go over to start the second. Second lag, then go start the third lag. This would be a banner point because it's just no reason for Ethernet unless the PLC with color. So this is low cost. I will use banners, and there'll still be PB2.
That little tiny band.
Oh,
where
yeah,
you
the
will-
little banner they just, okay.
Yeah. There'll be a PB2 gateway, a PB2 node. It's a little hard to see. This is a 10-mile radius that I have to work on for this spring for water fracking. The wells all over here.
Highly engineered system.
It is very complicated. We're still trying to figure this out, how to make it work. Everything has to go to booster and push 5 miles to a tank and monitor water in the tank from a level sensor and shut off and go back and shut off the wells if the tank is full, or fill this pit, which is 7 miles. Keep water in the pit for all these truck watering depots. There are 3 truck watering depots that are using banners connecting to the main panel. It works on its own. Then there will be Ethernet all the way back to Sheldon Booster, because you're reading the level in the pond, going back to Booster. The Booster's going all the way down, requesting one of these wells to start pumping water.
These guys were all here the last training, and it was a riot.
Yeah.
It was North Dakota boys.
Spent 2 hours making this whole sheet.
At the bar.
Yeah.
Yeah. Oh gosh, what is this? You know, sometimes Tom draws off and says, I'm going, what are you doing? Got a flow meter here, a well to 100 feet. So he's gonna run wire in the ground. Level transmitter in the deep well up to here, flow meter in the ground. Data cable. I guess he doesn't want to go wireless. But you can. So if you decide if you wanted to pull a conduit or go wireless, it will work either way. Remember, I said there were communication modules on. Anytime you want to under wire or wireless, you're going to get a communication module attached to the side so that you do not interrupt the communication to the drive. That's the whole reason we have a local communication. It keeps it more robust. So if a network is so big, I can put on several communication modules and go in different directions, but the cost just goes up. Anyway, that's it. Okay. Should I go through Charlie Creek Wireless? Go through it pretty quick. We talk about Ethernet radios. That's the first thing I would quote, and I would work it down. Cost, what makes practical sense, to what's lowering cost for what you're doing.
Ethernet radios have a tremendous amount of flexibility to be able to look from one device to another and troubleshoot and program. And these other radios are dumb radios. The only way to know what the health of the unit is to actually go connect to it or look at it. The other ones can all be done, and so all the stuff we do in North Dakota that Mike's talking about are all Ethernet radios, because you need to be able to get on and troubleshoot the radio and the device remotely. Otherwise, you couldn't support them. Because we have to support all of these systems, and they're out in the middle of nowhere, really harsh environment, and so if you can't do it remotely, then it's probably not practical.
Through that.
Not finding what I'm looking for, I'm gonna give up.
We do a lot of these wireless LANs for golf courses. If they've got multiple places where they want to access their computers even, you can create that LAN, and if they've got maybe a shop over here and something over here, clubhouse over here, and then maybe they want to be able to actually get on their ringbird system from one of their pump stations. So we'll create a wireless LAN, and then they just connect RDP to their ringbird system or to their whatever their central computer control system. So we do a lot of those, or they want to be able to have a tablet and ride around in their cart.
Well,
Oh,
they're using them,
Charlie Creek
they're
Wireless.
using them to run credit cards at the beer cart. too.
Are they?
Yeah. Yeah, that's why Mike had to come back from, where was he, at Bedford? It's to Spurwing, because they weren't able to charge people for their beer on the cart. Seriously.
Okay, Charlie, the whole planning the network. Charlie Creek Wireless, there's the river, up to the hill to a booster, and I guess that's a road. And this is 7 miles to the top of the hill, which actually is about 12 miles of driving all the way around to get up to the hill, but it drops down to a truck watering depot. So the guys guess she's all up, but that doesn't help me. So now I've got to come up with a plan how we're going to make this all work. There's our AC starter panel. Soft starter pumped up to the boosters. The boosters push up the hill 26,000 feet to a tank, has a liquid level sensor. And the number one priority is to keep water in the tank. It's a critical process because there are so many trucks driving back and forth during fracking season. They're going through and it cannot be out of water. So we put all these notes in we can think of between me and the customer. And there's the river pump pushing up to the boosters. I always ask, can you see between the depot, the tank to booster down the hill? They say yes. We've already got the thing perfect line of sight. Then I determine the right radios with the right frequency. If you have some hills or a haystack or a couple trees, then we will consider using 900 megahertz radios.
Is this the graphic from their SCADA HMI?
No, this is a graphic Mike developed from their drawing, from that drawing. Mike's drawings look like this, Tom's drawings are the one that showed you. We're not wasting any of them.
He doesn't even use a straight edge. He draws a line, straight in it.
Yeah, I'll get to that. All right, determine the hardware. At the riverside is a Ethernet, that's how you tell. Ethernet PLC with a 5-port switch, AC starter power supply for all this equipment, and a 5.8 gigahertz client proficient equipment, or CPQ.
Gives the customer an idea of what they're gonna have to do physically. We don't go out and install this stuff. That's up to, you and your people and your customers. We will, but it's really expensive. Dave just went and did one on a startup, and that wasn't too bad because I think they'd done most of it, right?
It's funny, I bought a 2-day plane ticket and I showed up there and he was on the phone with Mike finalizing everything being connected. And I was like, alright, I was like, the hard part's done, boys.
The mistake I did when we shipped that, I did not make him one of these. If he had this, he would have probably figured it out himself. If I label it, he would have go, okay, I get it. A repeater side, the well side, and the main side. So I had to do it all over the phone.
And this
But
was
the
a
good thing
customer
is, I
that
label
never
the
even seen
modems
one.
before I ship them.
Southern California, no, Central California, John Deere
Yeah.
Retech, shipped them a kit. They'd never seen any of this. I don't know that, I don't know if Greg had ever been to training or not here. I think
He
he
had
has.
no idea what any of this was gonna look like.
Right.
When we were talking to him on the phone, he's like, is there like some instructions I can follow? And we're like, well, there's instructions on how to mount an antenna inside an antenna box, but we didn't like detail how many steps up the ladder you gotta go. But he got it. I mean, as soon as he, you know, got the overview, he did a really good job.
So if I make this ahead of time and give it to customers, then you'll figure out how to put all the equipment and where they go. We did not get this. We tried to sell this, so I don't know where it was at. Some feedlot that you and Tom were working on, really huge, but it didn't go through. And this one, I don't even know what that is.
Well, if you do up a master plan like that, and a guy balks at the price, I mean, do you have an option of cutting off this, cutting off that, making it proficient enough, but not really?
Yeah, to a point that we don't feel like we can support it, because once you sell it to them, they forget about everything else. You know, the before of start chopping off the bells and whistles. Now all they want is, well, it's got to work. You got to make it work. Well, I can't make it work if you're too stupid.
The world I live in. It's
Right.
one of those things
You know
where they
what?
want to chop the knees right
Right.
out from underneath it, and then make it
You want me
just
to make it
exactly
work.
the Cadillac that they wanted to order in the first place.
You've got to have some ability on your end, and so we will not sell something that we can't support remotely, because it's just, we've done it, and you will eventually get it working, but every nickel that we made went out the window in tech support,
Yeah.
so,
Well, and then 2 months later, and then a year after that, and then 2 months after that.
so we just don't sell things anymore that we can't support remotely, because
True.
nobody makes any money.
If you did this, or if you did that, the PB2s, I have no idea the signal quality. I can't get on the radios. So it's all eyes and ears between me and you, and these, over the phone, testing the quality, connection and all that. With Ethernet, I can get on any of these radios and check the signal quality and determine the problem. Starting from here, from internet in, I got a router here and it forwards me to any of those radios in the feedlot. Very handy, very powerful.
We do this for municipal water systems, we do it for tons of things, but this was probably one of the first ones that we built, and they let us, if you want to bring up that site, they let us use this as a test bed, and honestly, we don't charge them anything to maintain it. To maintain the site or the electronics, if something breaks, we charge them, but we have a really good relationship with the J.R. Simplot company. Fantastic group of guys to work with. I've worked with them for 30 plus years, and so it's
So the control panel that he's remoting into actually has a computer inside of it. And the monitor is a 19-inch color touchscreen.
Rory,
In the front of the door, there's a swing out keypad.
there you go, you're looking at that map, I just showed you. Simplot feedlot is that map here. That's
this site.
all of this is this.
And that's
You
like
got,
the main control sector over there.
well-
Monitoring and controlling.
And you started this with those small radios and then upgraded and all that, and at this point?
Not this one, no, this one was a wireless LAN right off the get-go. We knew that you could not,
Pond pump station, from where you saw it right here, a man-made pond. Well, why did we do this? All these wells were running for years without that pond, running water over in the ditch and down into the creek, getting thousands of dollars in fines for letting all this runoff run back into the river and ditches. So, and they were running out of groundwater because they were constantly pumping around the clock, pulling all the wells and fixing them. A lot of money. So they made this big man-made pond and put in all drives at all these sites and fixed some of the runoffs. I don't know how much they saved, but
So they saved $400,000 the first 2 years.
that's a lot.
They only paid
Plus all the costs
$400,000
of
for
having
the
to pull all the wells and
system to
fix
begin
them.
with.
A lot of money.
Randy, how many
Anyway.
head of cattle are on that?
127,000 head of cattle.
That California?
No, it's here.
It's running right now. System flow of approximately 2,300 gallons. Some of it going, well, the dust control isn't working. So we put in 2 flow meters so it can watch how much water went into the stock water system and into the dust control.
So this system's running
It's
right
off
now?
for the winter.
It's a feedlot. They raise
Wow.
cattle.
That's a lot of water. Wonder if they have enough water for the dust control.
Well, they have the other pump station.
You have one pump running at 60 hertz, and it's doing 2,200 gallons a minute?
No, there's some cross the line lags in there too.
See the flow rate right here? 0, 0. The office well is clear over on the other side of the,
Oh, I got it.
there's 0, 0, and scale 2. Still, well, even that one is off. So, you can see all these wells are off, and only 1, 2, or 3 wells are running. Big savings in electrical bill as well.
And why is it, that 500 is offline, what is that?
The
They
nice
pulled
thing
it out
about
and they
this
just
is
never
you
put
use
it
the
back
log.
together.
Okay.
They didn't know, they didn't really have a good sense of how much water they needed, so they've got multiple wells. This is that user log that we talked about right here. But
This is nice, keeping track of, well, it's the same guess. They're not enforcing it, but it's still nice to know what people are doing.
so they're not logging on now.
They're all using
It's
the
handy.
same.
If you enforce it, you can put in users. Mike changed the set point. Dave changed the well set point, and so forth. Anyway,
See, look, somebody turned security off. I wonder who did that.
I don't know. Let's find out if we did it, if Roy did it, or if Mike did it.
No, Rory would have turned security off. That would have been Mike.
All right, back to Charlie.
Mister, I don't need no stinking security.
Start it all right. Got the river site connecting to the depot site. It's a point-to-point installation. That's a pair. Then you've got the booster site. Because it's 7 miles going up the mountains. It would go to this one, to the tank site. Then the tank site would go into the switch and back up the mast. And another point-to-point. Point-to-point, I'm sorry. Point-to-point dead end at the depot site that has a touch screen so they can see the status all the way back at the booster. Several miles away without having to drive the booster. Look at the touch screen, it's there from right here.
What were they using the water for?
Very nice. You can see the
They
touch
sell
screen is
water
in here.
for oil
See
fracking.
all the
Okay, alright.
Lots.
Lots of water.
Hey,
Yeah,
Randy,
it's-
is that
yeah, it's
the, is
ridiculous.
that the one where we built the, red, green, yellow lights?
Yeah.
And the truck drivers driving by could see whether the tank was full, whether it had enough for one truck, or whether they didn't wanna stop there at all. Just by driving down the road, they look over, green light, alright?
So,
Good.
like the oil sands in Alberta, similar to that?
These
yeah.
are the radios.
Exactly the same.
Let's talk about the radios a little more. How to tell it's an Ethernet radio? Well, see this? You don't see a jack. See the jack? Pull that cover off on that one. That white cover. Pull it off. There's your jack.
For Ethernet.
That is an Ethernet radio. No question about it. the radio itself is built inside the unit with the antenna on the front. Actually, on that model, no. How do you tell? See that connector on the bottom? Called an N connector. That is an Ethernet radio with a external and antenna connector. So that you could put like that round dish I showed you would connect to that model for long range, high gain. Now this one is an Ethernet radio with a built-in antenna on the front. 15 dBi antenna built on the front. What's the frequency? You need an ultra-model number. You cannot mix 900 with 2.4, with 3.8, with 5.8. It's gotta match.
Do you need to get FAA involved in that? Or FCC, or whatever it is? No.
FCC, these are sub FCC regulations.
Okay.
They're on 9 shifts.